Okay, so let's discuss a question from thermodynamics. So you have a well sealed room where you have air, enclosed air, and the initial condition of the air is given. So what is given is that you have a solar heat addition, okay, but at the rate of 0.8 kilojoules per second, and also you have a fan that is operating, okay, at 120 watts. Okay, now this is an enclosed system, closed system, so we have heat transfer, uh, okay, is equal to then we apply the first law of thermodynamics, where the heat transfer in the process 1 to 2, the net heat transfer is change in internal energy plus work done in 1 to 2. So now heat is getting, there is no heat transfer through the walls, so only heat addition is through the joules, okay, is through the solar energy. And so in 30 minutes, so 0.8 kilojoules per second, okay, so kilojoules is 10 power 3 and per second is basically in 30 minutes, so we multiply with the time, so we are looking for the total heat addition in 30 minutes. So 0.8 into 10 power 3 into 60 minutes into, 30 minutes into 60 for the seconds. So basically you get, if you kilojoules, I will write in kilojoules, so this 10 power 3 is not important, it will come in joules. So this will be 1, 6318, okay, so this will be, so this is basically 1440 into 10 power 3 joules, right? So this is the heat addition, and that is positive because heat is getting added by the solar energy. Now change in internal energy, how do we capture? We capture by MCP delta T. We assume that air is ideal, which is always the assumption, and so once air is ideal, for ideal gas you can use change in internal energy as MCV dt. And CV of air, we know it's 1.4, that is Cp, and Cv is 0.738. So Cp of air is 0.738, constant volume, specific heated constant volume, 7.38, okay, kilojoules per kg Kelvin. So this is Cp, which you are expected to remember, okay. So from this, so mass is given as, so we can substitute, right? Mass is given as 60 into 0.738 into dt. So remember, this is in kilojoules per, yeah, this is in kilojoules, okay. Okay, so now work done. Now work done, actually you have a fan which actually does a work of 120 watt. The work is in the electrical form. You have a motor that operates it, so 120 watt work is done on the system, right? So work done, if it is work done by the system, I'll take positive. If it is on the system, negative. So minus 120 watts, which is joules per second, right? 120 watts per joules per second. So I'll convert everything into time. So it's okay, so this is the rate, but if I convert into time, so it is minus 120 into time, and that is basically minus 120 into 30 into 60, right? So if I club all this and on this equation, so this is, so what I get is one, heat is 1440 into 10 power 3 joules, okay, per second, is equal to MCP delta T, 60 into 0.738 dt. Remember, this is in kilojoules, so into 10 power 3, okay, because this is in kilojoules, and work done is minus, so minus 120 into 30 into 60. So this, if I bring everything together, okay, so the left hand side will convert into, it is basically 12 into 3 into 6, so yeah, so the entire, this work done factor I can take to the left hand side, and So the entire thing will be 1656 into 10 power 3. You have to just add so this is, I mean, 3 zeros is 10 power 3, 12 into 18, which is 216, and 216 plus 1440 is 1646. Wonderful. Into 60 into 0.738 into dt into 10 power 3. So 10 power 3, 10 power 3 will get cancelled. Dt will be, dt is what finally we need to find out final temperature. So once you find out the change in temperature and add to the initial temperature, you get the final temperature. So 1656 by 60 into 0.738, it's 37.4. So the final temperature T2 is T1 plus dt, and let's see how much is T1. So T1 is given as 25, right? So let's come back here. So 25 plus 37.4, which is nothing but 62.4 degrees Celsius. So let's look at the options. 62.4, D is the option. So this is only thing where you need to carefully apply the first law of thermodynamics. The solar energy is the heat addition. Work done is negative because work is done on the system by the fan. Okay, so thank you.